Hello, everyone. Welcome back to integration, and we can start today with the some leftover from last term. So we're gonna teach the new topic. Actually, not new topic, but actually we were using in the exam one and a lot. It's called integration by recognition. And but in your textbook, we actually talk about the miscellaneous exercise, but which is like same meanings with integration by recognition. And in the next one, I'm actually upload some others the recordings, and I really want you guys to have a look and maybe give you more hints for what we actually how to do these kind of questions. Yeah, so we're back on this example straight away. So normally we're gonna using some like a derivative uh, with questions. Um, so first thing first, the question A they asking, let's show your derivative of fx, which is log e x squared plus 1 is equal to 2x divided by x squared plus 1. So as we know, let uh, y equal to log e x squared plus 1 first, and u equal to x squared plus 1. So du dx equal to 2x. So dy du equal to 1 over u. So dy dx equal to, so we're using chain rule, so we're using dy du times du dx. Hopefully just give you guys a hint. Um, so that equal to 2x over x squared plus 1. So this is a derivative. And now we're gonna using the derivative to figure out what is the 2 to 0 x over x squared plus 1 as anti-differentiation. So now we're gonna using the integration by recognition. So question B, so we know 2 0x to x squared plus 1 dx. Um, so can we just start with the we're gonna using the part A. Remember, if you're using part A to part B, normally we're gonna using as our um by our knowledge from the A. So first thing first, 2x over x squared plus 1. So that means we can use that equal to half and 2 0x over x squared plus 1 dx. So that means like 2 times half that equal to 1. So that means we can using that as our result. Uh, and we know derivative 2x over x squared plus 1 is equal to log e x squared plus 1. So which means that equal to half log e x squared plus 1 to 0. So now what we do is we just substitution in, and that's called the integration by recognition now. So we do is log e 5 minus log e 1. So log e1 equal to 0. So which means half log e5 is your final solution. So we remember we're using the connection between those two into your question B. So now what we do another example. So now we're gonna still using the integration by recognition again. So first thing first, we're gonna figure out what is the fy equal to cosine x over sine x. So we're gonna using the quotient rule. Does anybody remember the quotient rule then? So let u equal to cosine x du dx equal to negative sine x. v equal to sine x, and dv dx equal to cosine x. So now we know. So f dash x equal to, we know v square on the bottom of the fraction, so sine square x. And you're gonna using the minus du dx times v. Sorry, it's not. I mean, du dx minus v and dv dx times e. So now what we do is equal to sine square x, and then du dx, and that's minus sine square x, and minus cosine square x. So we know sine square x plus cosine square x equal to 1. So this is our formula we've been using so far, and we understand it. So we can leave the sine square x plus cosine square x outside the bracket and a negative, because they both have a negative sign. So now it's sine square x. So now what we do is minus 1 over sine square x as required. So this is question A. And now we do is question B. So we're going to figure out half pi to quarter pi and 1 over sine square x. Okay, so question B. Negative pi to pi 4 and 1. Sorry, it's 1 over, right? So 1 over. We say negative sine square x. Why are we using the negative sign rather than negative 1 rather than 1? Because the negative equal to positive. So now what we do is we can figure this out. So so pi over 2 and pi over 4, so we can understand that can be submitted, so that it can be equal to a negative cosine x over sine x. So using the integration by recognition, because we're using that part into the second half. So as long as we know this is your, so the derivative of negative 1 over sine square x is cosine x over sine x. So that's why we're using that. Now what we do is pi over 4. So now we just substitution in. So negative cosine half pi over sine half pi. So 1, 0. So, and then plus cosine pi over 4 over sine pi over 4. So, first half, we know they can be cancelled out. That become to 0. Sorry, that can be 0, and then plus root 2 over 2, root 2 over 2, so that equal to 1. So 0 plus 1 equal to 1. So, yeah, the final answer is equal to 1. Yeah. And now what we're going to use some questions like that. So we're going to using some CAS calculator part. I'm probably going to show you how we're going to use CAS calculator. But we actually know already, but we can refresh and recap about what we've been doing in term 2 and join the class, and then I will show you guys during the class. And this is integration by recognition, so hopefully that's understandable, and I will see you next time.